Good morning, students. Today we'll discuss the remaining 5 marks possible questions from the data structures. In the last video, we discussed up to arrays. Okay, today we'll discuss the remaining 5 marks question and answer. So today we'll discuss from the stack. What is a stack? Stack is a ordered collection of elements and it is a linear data structure in which insertion and deletion both takes place at only one end called top end. See here, insertion is also doing at the top end, deletion is also doing at the top end. It follows first in last out principle. See here, the first one was inserted and the element first 3 will be deleted. After removing a 2, then the 1 will be deleted. That's what. So first inserted element will be deleted last, or last in first out. So the last inputted element is 3. That element only will be deleted first. Then 5 marks question. So in 1 year it was asked the question, what is stack? Explain the push and pop operation on stack. That time 1 mark for the definition, 2 marks for each algorithm. And both the algorithms are very easy. First we need to check whether the stack is overflow or not. If the number of elements, that means the size what it was given, till that it is reached, top pointer if it reached, then the stack is full. If the size is 5 for the stack, if you inserted 4 elements, then it reaches to the n-1. The given size it was reaches. That time stack is overflow. That is, stack is full. We cannot perform the inserting operation. Suppose if the condition was false, control move to the else part. In the else, first increment the top pointer. First increment the top pointer. Then insert the element at the top pointer position. See here, the stack is empty. What is the value of the stack top now? It is a -1. Increment the top pointer first. Then it will become 0. Then insert the new element. The 0th position, the new element 1 will be inserted. Then suppose if you want to insert a next element, it is going to check whether it reaches to the given size. No. Then control will come to the else part. In the else, first increment the top pointer. See, earlier it was 0, now it was 1. And insert the new element 2 in the stack of 1 position. Similarly, perform. Once it reaches to full, then we cannot perform the input operation, that is called, gives you message called stack overflow. Here the size is only 3, hence it reaches to the given maximum size, hence the stack is full. Then what is possible? Now delete is possible. Then what is a pop? It is a term to delete or remove an element from the stack. First we need to check whether the stack is -1. That means the top is -1. If the -1, there is no element in the stack. There is no element in the stack. That time display the message called empty stack or stack is underflow. Stack is underflow. Suppose if the condition is false, control move to the else part. First remove the element present in the top. See, right now, what is the element present in the stack of top? What is the top position? 1. What is the 1? It contains 3. Remove the element. Remove the element. Then decrement the top pointer by 1 to remove the next element. Remove the next element. Did you got it? This will be repeat until a stack becomes empty. Once it becomes empty, then it will display the message called stack is underflow. Then another possible question. So it was asked in one of the year, that is, explain the operations of stack. See, first we need, if you want to perform any operation, first you need to create the data structure. Which data structure we are discussing here? We are discussing the stack data structure. Create an empty stack and assign the top equal to -1. Then empty stack created. Empty stack created. Then push adding a new element into the stack at the top pointer position. Insert the element at top pointer position. Where is the top here? Now it is 0. In the 0th position, first element will be inserted. Then this will be repeats if you want. Then for remove the element from the stack at top pointer position. What is the element present in the top pointer now? That is a 3 that we are removing. Peak. It just gives the top pointer position. Here peak is -1. Here the peak top pointer position is 0. Here the peak top pointer is 1. Here 2. Then here it will become 1. Why? We eliminated the element. We eliminated the element. Once we have eliminated, then the top pointer decrements by 1. Then is empty. Here we are going to check whether the stack is empty or not. If it is empty, display the message called underflow. Then is full, it check whether the stack is full. Here the stack is full, then display the message called overflow. Then size, number of elements present in the stack. Using a traversal, we can find the number of elements. Always the stack starts with the top equal to 0 till top pointer. Till the top pointer, where it was the element present, till that the loop is going to be repeat. It is going to give the number of elements present in the stack. That is your size. Then give the applications of stack. This is possible question, but till now it was not yet asked. But it was asked in one of the paper. It is in the preparatory. Give the application of stack. So what are the application? Finding a reverse of string, undo operation in your text editor, that is a MS Office, backtracking, language processing, conversion of decimal number to binary number, to solve a tower of an eye, expression, evaluation and syntax parsing, converting of infix expression into prefix or postfix, runtime memory management, and stock span management. These are the applications of your stack. Then algorithm for queue. Okay, we'll continue with the algorithm for insert an element into queue. Listen the students here. You will get the question, insert an element into queue or insert an element into a data structure at a rare end. Please remember, rare end is nothing but enqueue. Okay, inserting an element into the data structure at a rare end. Rare end is nothing but queue. Read the question properly. Inserting an element into array is there. Inserting an element into stack is there. Inserting an element into queue is there. If they ask directly enqueue, you can easily write. If they ask push, you can write. If they ask insert, then read the question completely, properly. Identify the question, whether they ask from the array, whether they ask from the stack, whether they ask from the queue. Okay. Here, if you want to insert an element into queue, first we need to check whether the rare pointer reaches to the given size. If it reaches to the given size, then the queue is overflow. We cannot perform the operation. Input operation. Then first check whether the queue is empty. If both are empty, make it to 0. See, look at here. So if both are -1, then we created an empty queue. Then make it both the pointer to 0th position. Okay. Then insert the element. Otherwise, increment the. See, if it is empty, then make it 0. Otherwise, increment the rare pointer 1. See, in this position, it is empty. Now insert an element at queue of 0. Queue of 0. What you are trying to insert, that element will be inserted at the 0th position. Now, front and both was pointing to 0. Then, Now again you want to insert one more element called 20. First it will check whether the size, what is the rare now? Is it a 0 equal to the given size? What is the given size? Here it is 4. Is it a 0 equal to 4? No. Control comes here. Front is 0. Is it a 0 minus 1? Is it a 0 minus 1? No. Control come to the else part. In the else, it increment only rear pointer. There is no increment in the front pointer now. So rear gets incremented by 1. 0 plus 1, control will move to the position 1. The element 20 insert in the queue of 1. Now the rear is pointing at a 1. Did you got it? That position, a new element get inserted called 20. This will be repeats until it reaches to the 4. Once it reaches to the 4, then the queue is overflow. That is, a queue is full. We cannot perform the input operation. First, what we are checking? Whether the array reaches to the given size. If it not, first we need to check whether it is a empty queue. If it is a empty, set both the pointer to 0 first. Then insert the element in the 0th position first. If it is not a empty, then increment the rear pointer and insert the new element. Then now we'll discuss the DQ operation. See, in the DQ operation, only front pointer gets incremented, a rear will be remains the same. So here we have taken one Q, in that rear is pointing to the 0, 1, 2, 3, 4, 5th position. There are 6, array size is 6, that means 7 elements. So here the position is 5, it was waiting, 6 it was waiting. Okay. Is both are minus 1? No. If both are minus 1, which one? Front and rear both are minus 1, then it is a underflow called empty. Then if it is not an empty, then remove the element present in the front pointer first. What is a front pointer? Front is in the 0th position. In the 0th position, 23 was there. That 23 gets eliminated. Then it is going to check whether the front reaches to the rear. No. Both are not equal. Then front increment by 1. Earlier it was 0. Now increment by 1. Now the front pointer is 1. Then is it a condition empty? No. Again control will come. Q of front. The element 2 will be removed. Then is it reaches to the rear? No. Then increment the front pointer by 1. Then the front pointer will come to remove the element 55. This process will be repeats until it reaches both the pointer at one position. If reaches both the pointers at one position, then set the -1 to make the queue as empty. Make the queue as empty. Hope you understood. Then, what are the operations can possible to perform on queue? Create an empty queue and assign both the pointers to -1. NQ, adding a new element into the queue at the rear position. DQ, remove the element from the queue at front position. Is empty, check whether the queue is empty. How we will come to know the empty queue? If both the pointers are set to -1, then queue is empty. Then queue is full. When you will come to know queue is full, when the rear pointer reaches to the given size called n-1, then queue is full. Then display the message called overflow. Then how you will come to know the size from the front pointer position to till the rear pointer position. How many elements are there? That it will use the size of the queue. What are the applications of queue? Once it was asked the question, 2018 supplementary or annual, I think so. So give the applications of queue. Simulation, multi-programming platform system, different types of scheduling algorithms, round-robin algorithm, printer-server routine, various features of operating system. In all these areas, we are using a concept of queue. Then we come to the end of the session. See here, algorithms, it is possible to ask, but till now there is no questions from this, but it is easy to write. First, create a new node and assign the address of that. Assign the address called PTR. Then insert the value into the particular new node. Insert the value here. And the link of this, what it was there, update it into the start. The link of new node, update into the head. Okay. And what it was there in the head, that update in the link of new node. Link of new node. So that the new node inserted at the position. That means earlier this node address present in the head. Make it that in the address of, that is a link of your new node. Then this address of the node update in the head so that the new link will be generated, old link will be destroyed. That is called inserting a new element at beginning of the linked list. Remove the element, delete the data element at the end of the linked list. First, traversal begins with the head. So up to control reaches to the end. Once you reaches to the end, so that null, make it in the previous node. Make it in the previous node so that the particular node gets free. Okay, this is called traversal from the particular position to till it reaches to the null. Once it reaches to the null, so update that link into the P1, then make it a free. This null update in the previous link, make it free. What is this? Dynamically we are removing the allocated memory called free. Yes, we'll continue with the previous year question paper. We'll discuss now with the previous year question papers from 2015 to 2019. In 2015, they asked two questions. That time it was two questions. So two annual questions. First one, explain any 5 basic operations performed on array. Traversal, searching, sorting, insertion, deletion, okay, merging, any 5 operations you should write. Write an algorithm to delete a data element from the queue, DQ algorithm. Explain the memory representation of stack data structure using arrays. So this I have given in the 3 marks question. Okay. Write, and the fourth question in the 2015 supplementary, write an algorithm to apply binary search. Binary search algorithm you have to write. 2016 annual first question, write an algorithm for insertion sort. Same year, second question, write an algorithm to insert an element into queue. Queue, it was a queue data structure. NQ algorithm you have to write. Then 2016 supplementary first question, what is linear data structure? Explain the operations performed on linear data structure. Please notice here, question number 1 and the question number 7 both are same. That means the operations performed on array and the operations performed on linear data structure are a non-primitive data structure. All are traversal, insertion, deletion, sorting, searching, merging. Only these operations. Please don't get any confusion here. So linear, non-primitive, one-dimensional array, linear array are only array. All are same operations. Then same year, second question, second question, write an algorithm to search an element in an array using linear search method. Linear search method. I think in the discussion, this algorithm was not given. Please follow the class notes. So the linear search algorithm. Then question number 9 in 2017 annual paper. See, what is a stack? 1 mark. Write an algorithm for push 2 marks and pop, it is 2 marks. Then write an algorithm to insert an element into array. 2017 annual second question. What are the operations performed on queues? Write an algorithm for deleting an element from the queue. Here, just mention the operations that can perform. Create, enqueue, dequeue, is empty, is full size. Then write the algorithm for dequeue. See, 2 times repeated question. Question number 2 and question number 11. Okay, we'll continue. 2017 supplementary, another question. What is sorting? Write an algorithm for sorting. Here 1 marks for sorting definition and 4 marks for sorting algorithm. Question number 13 in 2018 annual. First question. Write an algorithm to search an element using binary search. Then 18 second question. Give the applications of queue. 18 supplementary first question. Write an algorithm to delete an element from an array. Then 2018 supplementary second question. Define queue. Explain the different types of queues with a neat diagram. So this, I think this you have to go through from the classwork. Then 2019. Write an algorithm to delete an element from the queue data structure. DQ. Third times repeated. 3 times it was repeated, students. 2019 annual paper. Write what is primitive data structure. Explain different operations performed on primitive data structure. So here primitive data structure, the data structures that are directly manipulated by machine level instructions are called primitive data structure. Operations that can perform on only 4 operations: create, update, select and delete. Only 4 operations, each one 1 mark. Primitive data structure definition 1 mark. Then 2019 supplementary. Write an algorithm to insert an element into the queue data structure. Queue data structure insertion in queue. 2019. Explain the different operations that can performed on stack data structure. So what are the operations that can perform? Your create, push operation, pop operation, peek, then size, is empty, is full. Okay, na? Any 5 operations you need to write. So here 20 questions are there. So each paper 2 questions. Another 2 papers are there that we'll discuss in the offline class. Okay. Thank you, students. This is your revision completes for your 5 marks with related to data structure. Thank you.